Now we don't have to talk about Mass Effect anymore. Okay. Okay.
On the video.
So, design patterns. I don't have anything prepared. Just everybody read the chapter, and here we are.
There's a bunch of patterns. Some of them I recognized, some of them I did not. So be fun
Just
to
the
get into them.
introduction we were reading, though, correct?
Yes.
Chapter 1.
Yep. Chapter 1. Chapter 2 is really exciting, actually.
Chapter 1 is just a broad overview, right? Isn't it just the getting into it all and how do you describe a design and all that? I don't really know what there is to really talk about or dive into any of that, but
Good reading, everyone.
Hey, I'm glad I didn't prepare for 2 hours. Fine, I'll start things off. Okay, so this book is 25 years old. If you have ever used a singleton, if you have ever read anybody talking about a singleton, it's from this book. This is the source of everything. It all began here with these people. And this Grady Booch guy, okay, he's one of the creators of UML. And it was a big deal to get Grady to endorse this book. This came out in 95 and UML came out in 97. So
yeah,
the diagrams are probably Booch diagrams, because there used to be 3 different people that all had different nomenclature for the diagramming, and that's why they created UML. They finally got together and brought everything together. So that's why you see the diagrams in here. They're like, wait a minute, that's not what I see in UML. Yeah, because it's the precursor of UML. And so you put your data types first and then your methods and signatures below, for instance.
Oh, really?
So,
they were describing it as UML in my book, so I don't know. But
oh really?
I think it was flipped from UML. But I mean, it's very similar.
It's very similar. It's just slight differences. They called it different. What was the? I can't find the name of it. They had the actual name in the book.
They did.
I'm wondering if I read a different book, or at least a different part of the book, because mine was all about like inheritance and polymorphism and stuff like that.
They talked about that. Yeah, they talked about that.
Oh, okay.
Mentioned it, yeah.
A little bit.
Yeah.
Okay.
I think
cool.
Right.
I did read the same thing. Good.
So
OMT based notation.
Yeah, OMT. Yeah. It's been a long time since I have read a pure software development book, right? Like, this is true computer science, like building software. They're talking about writing device drivers. Yeah, you know how you write a device driver and stuff, right? Like, here's the way that you go about doing that, right? Like, it's been a while since I read that, and it brought back good memories. Actually, like, I've been kind of out of touch with that, I guess, for a while. Everything I've been doing has been very game oriented or business oriented or whatever, and but this is like the pure thing. They're like, Tyler, did you like how he was talking about model view controller right after?
I was reading. It was like, oh, like I read it yesterday, and I was going through it. It got to MVC. It was like, wait, Thomas must have read this chapter before we had our conversation, or
20 years ago, I did.
20 years ago, and then and it's like, okay, well, it's literally here. We literally talked about this, and it's literally here.
Yeah,
I just needed to read it like a couple of days beforehand.
Yeah. So that was great to see. So, Tyler was struggling with something, and I was like, oh, okay. Model view controller. Let me just explain how model view controller works. And then maybe you can see how you can solve your problem, right? It's not a one-to-one, but it's like, here's conceptually how MVC works. And it's not always MVC. Sometimes it's just MV, model view. But conceptually, here's how it works. Now let's apply that to the maps and the hex features and whatever. Yep. So I thought that was cool. But it was refreshing to read a pure computer science-y book again.
Yeah. I say for me, like, I'm not even a year out of university. A lot of this stuff that's mentioned, or at least they talked about in here, is something I've heard about, but like the class I took on algorithms and data structures, there's nothing about design. Like there was no classes anywhere about designs. They would just sort of mention it, and if you needed it, you would kind of look it up and figure it out. And so it was kind of I would also say refreshing or re-bringing up things that I hadn't really thought about or remembered since university. So
yeah, I mean, I'm
that way it's
similar here. I think it was just called software. What was it called? Software programming or something like that class, which they touched on this stuff, but they never like having a textbook like this that went through it. It was a bit more formally was actually really helpful, and they touched on it, you know, and probably loosely in different parts rather than all in one place. And it would have been really good to have this like sort of explained in this way, I think, rather than you know, like, yeah, I felt like I had some of this stuff explained well and other bits like missing. And so to have this sort of formal textbook to go through actually was hugely helpful.
Tyler, Sean, I don't know how you felt about this. Do you feel like your university classes were giving you the answers before you had the question?
Somewhat, like to some degree. I would say, yeah, in a lot of instances, it would be like that.
Because you just said,
Yeah.
Tyler, that you're not even out of school a year. You came up across a problem where MVC was part of the answer.
Yeah.
So you very well could have been in university, and they maybe even talked about MVC. You weren't paying attention. You're passing notes in class. You're playing League of Legends on the side. Right? Like you very well, it could have come up. It could have come up. I don't know what your courses were exactly, but they could have come up, and you're just like,
yeah,
okay, neat.
Like definitely, there's so many things in university where it's like it came up, it was talked about or mentioned maybe once, where I literally have an hour or 30 minutes of experience, so to speak, in a university class that I didn't compartmentalize because it wasn't really, you know, either critical to myself going forward, or I was distracted, or, you know, I have friends in the class because the classes are small enough that you're friends with everyone. So like 100%, like MVC, I have 110% heard of it. It's just I couldn't for the life of me think about what it was or recall it to bring it up when I needed it. Right. So that's kind of what the I would say is I would agree. You are given answers, but you're not really given the questions and like reasons why you should be using XYZ for an XYZ problem, right? Like it's here's something you can do. Now use it or don't use it. Kind of that's kind of what a lot of the education was, or more informational based, or I don't know. I took a lot of computer science classes on the history of computer science or stuff like that, or like the development of languages. But there was nothing really design specific stuff like this. Nothing kind of nothing. None of my classes really went into these, like the list of 23 designs that they have here. So yeah, that I would agree. Like the answers before questions.
My experience is very different. I would say no. I think part of that is to do with how it's structured here. And like, I haven't done, I guess, the paper that would answer my questions around model controller view and the UML stuff. Like, I happen to knew it because I had classmates who chose to do that paper and were talking about it. But yeah, like I haven't found that I had answers. Like, maybe I didn't know fully how to use something, but I definitely didn't have answers before questions. Like, I felt like the stuff I'm learning was relevant in some way. Like even if I couldn't fully conceptualize exactly how it would work, I could see its relevance. So maybe I'm just lucky in that I didn't have the same sort of experience where it's quite disparate. I don't know. Papers here seem to be pretty focused in general. So
By paper, you mean class, correct?
Oh, this is the confusing thing. Yes. When I say paper, I mean like a course or class. So,
Okay.
Yeah.
Thanks, Tyler. Yeah, thanks, Tyler.
Yeah. I don't know. I already had this discussion. Yeah.
We should probably all look up some New Zealand terminology. So
Yeah.
that we,
So
communicate better.
that actually explains a huge thing. So I'm talking with Sean, and he's like, I'm like, so you're doing computer science? Yeah. I just have 3 papers left.
Yeah.
And I thought like how
right.
people are taking their masters. They're taking a master's and they have to write a dissertation. They have to defend their dissertation. So he's like, oh, he just has these 3 papers. He doesn't have to go to class or do anything, just to write these 3 papers. That's what I thought.
So much. This is how I tricked you into hiring me.
That's right. That's right.
Yeah.
I didn't know you're 3 classes short. That's a different discussion.
You just had to speak in New
Pick up the
Zealand.
short. Like, glad we got that on the table.
Yeah, I had no idea until this moment. That's great.
Yeah, me and Sean had that discussion the other day.
Oh,
and,
okay.
And he was mentioning papers, and I was like, "What on earth are you talking about?"
Like, I didn't have to write papers in my CS classes. They had me write code.
Yeah,
Well,
I thought that was
had to
weird
write
too,
papers. So.
but whatever. Okay, got to write some papers. Okay, essays for computer science. Whatever.
Yeah.
Thankfully, those a few.
So I
I think
thought I
that
would
speaks
clear
to
that
one of
up
the-
for everyone here at the just making sure we're all on that same page.
I think
That's
that
good
speaks
to
to one
know.
of the benefits of design patterns, though. It's like giving a name to a thing that you've seen before. And like, if you don't have that name, you call it something else. And then you get this confusion
Oh.
where it's like everyone's doing the same thing, but they call it something else. And I think that's one of the nice things about these unifying patterns where, hey, if you're doing something that happens to that mold, you now have a shortcut for communication, which can be really helpful.
That is, I think, the big benefit of going through the book together is that we can actually talk at that level, right? Oh, flyweight. You should use flyweight. Okay. What the heck are you talking about? Google, right? So yeah, that's great. One of the benefits I see of doing this is you've all struggled with programming something at this point, right? I don't know how much you struggled in school with an assignment. From what the little bit that I've seen, the school assignments are very basic and simple, but I'm not. But now you've like struggled with like, how the heck am I going to do this? And now the answers are coming. Now the answers are coming. You do it like this. So we all have our own individual things that we've had to struggle with. You know, Tyler's working on the map and trying to understand how to have features on a map thing. And Josh hasn't had to deal with that, right? That's fine, but we all have our own different struggles. So different patterns might leap out. But ultimately should be walking away with like 4 or 5. They're like, if only I had known about that.
Yeah.
I'm hoping that'll be the case.
One thing that I can't think of a way to make this a question, so I'll just make it a statement. So early in the book, he says something I found quite profound, that the difference between a junior programmer and a senior programmer is the patterns. It's the I've seen this before. I know what to do, right? And so as you skill up, as you work as a programmer for a longer period of time, things start to be like, oh, that's one of these, right? Like it's not exactly the same, but that thing that I used before that I really struggled with to come up with, or whatever, that would probably apply here as well. And that's it. That's the difference. So this book is like 5 years experience just being like put into your brain, right? So if my head was a giant NES console, and this is the cartridge that I could just put inside, right? And so yeah, it's
where I ask what's an NES. I'm
you
sorry.
not know
That was
what it-
mean. I'm sorry.
Do you not know what an NES is?
No, I know what an NES is.
If you didn't, then
I
I
got
wouldn't
the
want to be
NES
like,
classic somewhere
oh,
Yeah, it's this small little thing, right? That has an HDMI that goes into your TV and lets you.
Yeah,
play
of
it.
course.
That's actually shaking his head.
Yeah. It hurts.
Wait, did we grow up in the era of N64s?
I was more so in the area of N64s, but I started with the NES and made my way up because we were
Right.
behind
Right.
for whatever reason. I think because it was
I did
great.
not.
When we have
I did
meetings
not
with
grow up in
when we have meetings with Mark Webster and I see Super Mario 3 and Final Fantasy behind him, I get hit with a nostalgia. Super
Thanks.
Mario 3 was my first game, and I also had the original Final Fantasy. So
Oh,
it was just it gets me.
Yeah, I bet. Yeah.
Final Fantasy
Super Mario
1
3 is good.
let you make your own party. Like you could have
Yeah.
4 white mages off you
Yeah.
go. And
Yeah,
even
you
if it
could.
wasn't optimal, you got to choose that, right? Like you
Yeah.
got to try. And they never did it again.
Yeah.
Not even once in 14 sequels will we ever let you choose your party again.
Probably because people would pick a bad party and be like, man, I can't win the game.
Yeah, I
The
mean,
game sucks.
yeah.
Let's nerf. My white mages can't hit things hard enough. Basic attacks don't work.
I suppose technically in Final Fantasy X you can, but you have to choose the expert sphere grid and then just like throw caution to the wind. It's not quite the same, but in theory you could do it.
Zach, I'm curious how you found reading this book. I know you went to school for music, so I don't know how many of these kinds of books you've read. I assume some.
Yeah, some of them are familiar. Some of the patterns are names that I've heard before, but I haven't actually gotten around to studying. But there's a few that I have run across before, like obviously Singleton and some others like Adapter and yeah, I don't know. There was a few where I was just like, oh yeah, I've used that or used something similar, strategy, prototype. But yeah, then there's some other ones in there that bent my brain and I wasn't quite sure what to think about it. Like bridge pattern was like decoupling abstractions from implementations, but I think of like an abstraction as decoupling other things from implementations. So I don't even know what that looks like. I wasn't sure how to read that. So yeah, some familiarity, some not.
Yeah.
But I was really heartened by reading the description of like how they're going to present each one, because it looks like they hit all of the patterns from a lot of different angles. Like they want to try to provide the question along with it. So and comparing them to each other and being like, this is where you might not want to use this pattern and that kind of thing. So so it sounds like it's going to be a really good read.
Yeah, I like that they specifically talk about problems and benefits of things rather than just being like, and this is amazing and this is why you should always use this, because that's just, I think, a red flag for any programmer. Is that it's just this is the way you should always do it. It's like maybe in your context, but it's not every context.
Life is pain. If anybody tells you different, they're trying to sell you something.
I've also heard the thing too, where like somebody gives you a hammer, then everything starts looking like a nail. So it's kind of good to know, like, oh, maybe the hammer isn't always the right thing.
The fact system will solve everything.
Yeah, right.
Oh, crap. I don't know why you all like moved on perfectly fine back then.
FACT. Michael's fact system is the hammer.
Oh, we're doing serialization right now. And I say it will work, because if it doesn't work, we'll have to change it to make it work.
True.
So how much of this book is going to be in small talk and C++? Like, well, C++ and small talk, but like small talk, like I don't think I've ever seen that language like
Well,
I've never even heard of small talk, actually.
In 1995, they said, people are starting to really adopt the C++. and Smalltalk too. So who knows which the winner is going to be, right? So
C++ it is.
yeah.
The impression I've always got that Smalltalk was really popular among hardcore OOP people. So like all the people
Oh,
all the people who are writing this book are working in Smalltalk and C++. And so they're like, we love Smalltalk. We wish everyone adopted. And then nobody did.
Isn't it like a university teaching language, basically? Like, so it's like all the academics are all like, yeah, Smalltalk. And then you step outside and nobody uses it.
well, I mean, from my experience, it's all Java, Python, and is it Ruby or R? Which one is the scientific language?
R is the scientific one.
R.
Yeah. What I'm
Ruby is
saying
weird.
is those languages didn't exist in 1995 when they wrote this
Oh,
book.
yeah.
I didn't
okay.
say academics today. I mean academics.
Okay.
Yeah.
I did see a Smalltalk thing on one of the lecturers at my uni. Mind you, my uni's weird in the sense that we have a lot of like programming language people. So like pretty much everyone here has their own programming language. So it's like, yeah, it's pretty interesting.
Yeah. I guess like something interesting, like they were talking about different designs in here. So like an iterator was before sort of modern languages, did you have to literally like make your own iterator? Like, because C# now has like, so to speak, standard iterators for what you need, and you can kind of make your own custom ones. But before that, like were languages like not defining that at all? Like you just had to figure out how you wanted to iterate over something on your own?
Correct. So you could program in C++ and you would not have a list and not have an iterator and not have a for each. You just had a for loop and strings. You didn't have a string. You had constant characters in memory that you could point at, right? Static const car. But you didn't have anything, really. You didn't have anything. And it's because of this stuff, right? The iterator patterns, like, oh, that's so darn useful that we can just add that in a sense to the language. And that's where C++ really came into its own with the standard template library, STL. So this was a big realization that I had as a professional programmer who was then doing C++. And like I had been studying C++ and playing around with C++ in my DirectX programs or whatever, but I was like, yeah, it's cool. You can have classes and polymorphism. That's kind of nice, but I'm not really. And then the technical architect that I worked with that gave me this book and a number of other books, he was like, no, you got to use STL. I'm like, what is that? And you go to STL and it's basically .NET. Like whatever you see in .NET is from STL. And so there's the guy who created C++, it's like Benjamin Strausstrup or something, is like the guy that like
Johann Strauss, I believe.
Thank you. See, I was pretty close. Again, we're going back 20 plus years. So that's like the guy who creates C++. And then he went on and created STL. And STL like gave you lists and iterators, string composition that you could modify things and whatever. It gave you like all these things. And so I was like, oh, okay, now I see how C++ is so useful, because C with a library of functions, like it doesn't equal C++ with STL. And so that's the path that you get to C#.NET, right? So this C++ STL turns into Java, and then Microsoft makes their own version of Java called J++, and then, or not Oracle, Sun Microsystems owned it and sued Microsoft and cease and desist, and they're like, fine, C#. So that's the path.
Yeah, that makes sense.
And like some of these things have just been baked into the language. So like you're talking about the iterator there, but the observer pattern is baked into C#'s events now.
Right.
And so there's like other ones where they've made it into the language level, and then other ones which haven't, and you still have to like go build it because it's too dependent on what you're trying to make.
Yeah, that makes sense.
So Michael, you always wanted to study this book. You've brought it up several times as an option for us as a studio to do this. I'm curious.
Yeah. I mean, in college, I did study it. So like I had a class on not this book, but a future version of the book, which was more Java centric or whatever. But it was very much like Tyler and Sean, like that wasn't the emphasis of the school. Like it was like this experimental class that was like a 1 month thing over the holidays or whatever you could do. Yeah, so I always liked it.
Was it a class or a paper?
It was a paper. The original itself it's different because it is sort of like stepping back in time where you're like, hey, here's a lot of stuff where things just didn't exist yet. And you're like, oh, okay, well, that's interesting. And so it's weird to try to have to separate out, or it's here's the stuff that came out of this book from here's the stuff of this was only important at the time. So that's interesting to sort of have to go back in time, I guess, to sort of think that through. But I'm mostly just excited for design patterns being used across the board, just for the sense of like I mentioned before. So if we're mentioning, hey, we could use a decorator here, we could use the observer pattern or whatever, we have that design language. And also I think it helped when I was trying to figure out how do these patterns work? Like, how do I think them through? It then helps me think through other problems because it allows me to see how object-oriented approaches allow you to tackle things that aren't just like creating ducks. Because like when you learn about OOP in class, you're like, okay, you could create an animal and then you can create a duck that subclasses from an animal. And you're like, so that's fun. But like, when am I ever gonna do that?
Next time I write my zoo software, I'll be sure to think of OOP.
Yeah. But when you're thinking about it this way, it's how you can create your own patterns or your own, how do you use the language of objects rather than just how do you, yeah, I don't know. But I mean, like I was talking to Tyler the other day, I'm like, so I did it this way because I thought it'd be easier to use composition rather than inheritance. He's like, what's composition? I'm like, oh, have you read the chapter yet? It was in there. And he's like, nope, not yet. And I'm like, oh, okay, well, we'll get there. But I don't know, but that's what it is for me. It's interesting. It is tough reading because it's sort of like going back in time. But I hope it will be worth it. What?
Yeah, the vocabulary in it is kind of a tripping point for me, definitely, because they talk about like types in one way, but then I was thinking like type equals class, but that's not true in this book. So yeah, that's something that I think I still have to grok on a little bit and kind of will take a bit of time for me to get used to.
I don't know if this helps anybody, but in C++, nothing inherits from anything called object. Like if you just go class blah, that's it. Like the hierarchy ends there. It's C# and I assume Java, where there's the one thing, the object of which everything comes from. So that would be a pretty big difference when you're maybe looking at the examples and they're talking about these things, just to know, oh, not everything inherits from one thing. And there's another thing actually that I just remembered. They're talking about mix-in classes. That's impossible in C#.
Yeah.
Oh, is that like multiple inheritance?
Yeah, multiple inheritance.
Yeah, right.
So that's something you can do in C++, but you can't do in C#. And you get around it with interfaces. Yeah.
I believe Python has also got inheritance similar to C# and Java. So
I don't recall if Java
I'm curious.
Inheritance.
Java,
I'm sure Java doesn't let you.
Yeah.
Yeah, it doesn't either.
I think only like your pseudo through your interfaces or however you want to do that.
But now we have default implementations for interfaces that we can do, so it's a little bit closer.
Sort of.
I'm curious, like, what's the advantage of multiple inheritance? Because I only ever saw it as like a painful thing to do.
Well,
that's what classes always sort of like tell you about it. They're always like, okay, so you never want to do this, but here's why it's bad.
Yeah, it's an object that can show itself multiple ways, right? Without a cast, in a sense. So,
right.
How handy would that be in Archmage, where a monster can also be a character? right now we're forced into a hierarchy that monster has to inherit from character, which kind of doesn't make sense. There's a lot of things like going to bed and kissing your wife goodnight, whatever, that we don't want on a monster. You get that with multiple inheritance anyway, where you inherit and you just get all these things. And so anyways, it does solve the problem of you can just throw these things around in your software and it just behaves the way that you want it to, or you just throw it around in the software and it kind of doesn't matter. And now you're forced into like a cast explicit conversion on it. It's like, oh, you want me to be one of those? Okay, and then I have to go in and code all like to make it look like that.
Maybe I misunderstood, but I thought that was the purpose of interfaces.
Interfaces allow you to do some of that, but it doesn't allow you to have default implementations until now. For things where it would allow, so you can't use code reuse that way with interfaces. Interfaces don't give you code reuse; they just give you API interfacing, which is great and is wonderful, and I will use it all the time. But it doesn't give you that code reuse, which I think is also why I tend towards composition rather than inheritance in C# for code reuse, just because you don't have that multi-inheritance setup. So if you want to have something doing it the same way across multiple different class bases, you just have somewhere where that object exists and you can delegate to it.
Well, Chapter was saying that you should favor composition anyway over inheritance. Like inheritance has its place, obviously, but
Yeah, I'm definitely a fan of composition over inheritance because I guess I don't know if I misunderstand how multiple inheritance works, but when I hear that, I think of, okay, I've got two objects with similarly named variables and I'm mashing them together and hoping I grab the right stuff in all of my calls. That sounds awful. I'm sure there's cases where you can be very purposeful with it and it's not that bad, but I just am afraid of all these things that I could see coming from that.
I think that's why a lot of languages don't let you do it. It's because there is a lot of problems that come up.
I could see so much awful code coming from that. Just if you have a junior engineer who uses it in a bad way, it could just cause so many problems.
Yeah, that's how you get spaghetti code real quick.
Yeah. It's like, well, wait, why is it able to call this? This object doesn't, oh, it's from this other one that inherited, and then it goes 3 layers back, and now that's where okay.
Oh, yeah, multiple inheritance on top of multiple. I didn't even think of that. Oh my goodness, that'd be messy.
Multiple inheritance.
scary stuff.
Yeah, you get a spider web very quickly instead of a tree. Yeah, I could see how that's hard.
I don't know if it's worth discussing since we can't do it in the language. But theoretically, like, let's say that you can make a list and you can throw a house and a person on the same list, and like things that are damaged by this event, and houses and persons, and you're able to get them on the same list because you have multiple inheritance of the data object, and that's impossible in C# because it can only be one thing. So
the things that drives me mad with C# is generics. So like I have all of these facts which all like store some type inside of it, and they're all pretty much the same thing, but they have a different type underneath, and I can't have a list of multiple different types of the same thing in the same list. So I either have to cast everything to an object to sort all dynamically like that, or I have to keep them all separate.
This is maybe where I'm getting confused. I thought an interface would be how you'd do that, and you'd set up an interface which has what you want, and therefore you'd build a list of your interface.
I've tried to purchase it like that, and you can do that, but your interface, if you need to get data out of it, won't be able to provide you the data to get the data out. So you can store all the data in one place, but you can't access the data.
Wouldn't you, this is what I would have thought in your interface, you would have a function that allows you to do that. Maybe I'm not thinking about this properly.
But you have to have a return type specified in your interface fund. And you can't have a return type specified when your return types are changing. It doesn't really matter. It's just one of those idiosyncrasies where C# I've just sort of like banged my head over it for a while trying to come up with some solution and never got anywhere.
And your multiple inheritance would have solved it. Yeah, I see.
I could be misunderstanding, but can't you just use like T where and limit it if it's on a method? I've done that in multiple cases where I'm like, well, this is generic, but it can only be these types. Maybe I'm misunderstanding your use case.
Some, but not all the way. Like generics essentially are creating 10 different separate classes, essentially.
Right.
It's a new class for every different type of thing you've passed through it. And as soon as you have a different type, those things aren't comparable anymore.
Yeah, that's right. I see what you're saying. You can't pass 2 different items of different types into the same instance of that.
Yep.
Yeah.
So that's why, Josh, in the first draft of this, we had to have 3 different parameters going into a simple thing where you just say, hey, this is fact name and it's a string and it happens to be of a type fact name somewhere. And you're like, why do you need all this? Because I couldn't find another way. But anyway, that's
Anything else about the book?
The conclusion I've come to is I read the wrong book. So I just did it through
Did
the
you read-
O'Reilly thing. And I somehow got on the wrong book. So I'm gonna
What did you
obviously similar enough. Like there's some stuff that you guys talked about that I haven't covered.
Doesn't it look like this?
It did have that picture. That's why I thought it was that book. But I'm realizing by the stuff you're talking about, I haven't read the same book.
Well, the multiple inheritance thing was only like 1 paragraph.
yeah.
No, but it's the patterns as well. Like the composition, it touched on it, but didn't explain it. Whereas it seems like your book explained it.
No,
I'm pretty
No.
confident.
It was just
Okay.
mentioned.
yeah, it was
Okay.
just
There
mentioned.
was like a paragraph or 2 on composition, but
Yeah, they just
Okay.
started
All right.
listing out things and
I didn't see anything about flywheel either. So
no,
I
that's
just
all
meant
coming.
it's what that's a lot of that's all coming. It's just giving a summary of all of that. So there is.
oh no,
there is
but
some
it didn't mention flywheel whatsoever. And all my examples
Really?
were different. I didn't have any small talk examples. So I think I read something different. But
Small talk was mentioned.
I'll let you know.
Small talk was mentioned, but we didn't have any examples. Could you just like send us a screenshot or a link to the book that you read, and we can just
Yeah,
Yeah, sure. I can do that.
it's possibly of a different version. They might have gone in and stripped out all the small talk.
you can totally see
Uh,
someone doing that.
Wouldn't be unreasonable.
Yeah,
You mean we aren't going to become a small talk studio now?
no,
I think we should become small talk. We should be the
Unreal
first
doesn't support
game
small talk.
engine.
Darn it. Let's just make our own engine, our own small talk engine.
Yeah,
Oh,
Jonathan
you can get
bloated
right
it.
on
Small
that.
talk interpreter. Let's do that. Interpreted small talk into JavaScript that we then use the V8 engine to compile into WebAssembly.
Can somebody get
Wow.
Jonathan Blow to add small talk to his game?
There you go. Yeah.
You know he ain't gonna do that. He's gonna roll his own.
Okay.
It's like he's what he's done every time.
That's right.
John, your
Next thing
book
you know,
there-
he's gonna roll his own version of assembly, you know?
No, his own OS. In order to really
Yeah,
make
right.
games, you need
Oh, yeah.
this OS.
Right.
And then with my tools, then you can make games.
And then his own hardware manufacturing line and everything.
You're joking,
Funny thing
but I
is-
feel like he would do that.
Funny thing is, there's actually a YouTube channel where a guy was like creating like Pong, the game. So he wrote his own like game engine and he's like, you know what? That's not low level enough. So he wrote his own OS. He's like, that's not low level enough. So now he's literally making his own like breadboard computer, then going to write an OS for that breadboard computer and then write a game engine and then write Pong on that
Wow.
computer.
I was very impressed with his Pong OS. That was a cool thing.
Oh, you've seen that?
Well, I've seen parts of it. I didn't watch the whole thing.
Okay.
Yeah.
We've lost Thomas.
Yeah.
Sean, just so you know, that book is not the design patterns book. I was looking
Yes.
at the title and it's object-oriented thought or something, which is
Thought
not
process.
right.
Fifth edition.
Yeah.
Or thought
That's what I
process,
mean.
excuse Yeah.
When I found the list, it had the design patterns book. So I was like, oh sweet. But then like it's clearly not the same
No.
thing. I found out. Yeah, I was pretty
Um,
confident I was not on the same page as you guys.
Oops.
Oop is great.
I did put a link to
Literally
the
about
book.
Oop.
I thought. No. Yeah. Okay.
You
Yeah,
did, but I
there's a
went
link.
through the O'Reilly thing that you suggested.
Yeah. Yeah, that thing's great. I love that thing.
Is that worth keeping?
Okay.
Probably. One thing that's just a fun tidbit about the book, one of the authors in their sort of like whatever you call it, mentioning, oh, it's to this person or to this person,
Yeah.
just throws Joshua 24:15 in there. And you're like, I don't know why that's there, but it's there.
That really struck me when I read it the first time on the train in 2000.
Wait, 24:15?
Yeah. As for me and my house, we will serve the Lord.
Oh,
That was his kind of acknowledgement thing on the very first page.
I heard my name, so I just got confused.
Oh, sorry.
I was a bit
Right.
confused as well. I was like, Josh is around then in a way that was important to this person.
Is there a
Very
page
much so.
or something in the programming book that
That's
we
right.
talked about before? Checking the Discord.
Wait, Joshua 24:15.
Yeah. As for me and my house, we will serve the Lord. That's the
Oh yeah,
verse.
yeah. There we go. I was reading the whole verse and I was a bit lost. I'm not seeing it until I got to the end. So
Yeah, it's the B part of the verse.
yeah.
Where do you mention that?
Sorry?
Cool. Okay. Anything else before we go?
Not for this, but it sounds like Sean's struggling with the menu system, and I don't know who's knows that well. Like Thomas, you wrote it originally.
I did.
Back like when this book was written. I
Oh, wow.
don't know. I've touched it a couple times here and there, so like I can jump in, but it's been a while. And I don't know if Josh or Zach have any more recent knowledge of a menu system, but
I started looking into it today, but
There you go. Okay. We can have a quick powwow about the menu system and buildings.
Yeah.
Okay.